Okay, so we're solving exponential equations again today. The difference is now we can have fractional exponents, okay, and radicals and solve them, okay. Same idea as yesterday. We're going to do the same thing where we have to get the same base on both sides and then set the exponents equal to each other. So we're still solving exponential equations. They're just harder versions of yesterday's ones. Okay. All right. So solve each exponential equation. So x is in the exponent. We know it's an exponential equation. So we've got 3 to the x, and we want to ask ourselves, can we rewrite 27 as 3 to the something? Yes, it is 3 to the? Good. So I'm replacing 27 with 3 to the third, but that's still to the 1/2. And when you have a power to a power, multiply the exponents. Good. Keep the base and multiply the exponents. Who can tell me what 3 times 1/2 is? Hopefully lots of people. 3 over 2, good. Okay, so now that I've got the bases the same, and I've got base to exponent equals base to exponent, I can set the exponent parts equal to each other, so therefore x equals 3 over 2, and there's no other solving I have to do, so that's the answer. Value of x. Okay. Next one, so 5 to the 3x. So the first thing I would notice is that 125 is written with an exponent. Okay, so I would want to write square root of 125, unless it was a perfect square, like then I would take the square root, but I'll write it as an exponential. So 125 to the exponent of 1. Okay. Now I want the 125 to the 1/2 in the numerator. So in order to do that, the exponent becomes negative 1/2. Okay. So first I rewrote it from a root to an exponential. Then I want it brought up to the numerator. So I have to make the exponent negative. Now I want to see, can I write 125 as 5 to the something? Five to the power 3. You have your you have a lot of them written out for you on the last page of your last note, if you want to have that out for reference as well. So 125 is 5 to the power of 3, but that's still to the negative 1/2. So I've got 5 to the power of 3x is, now I have to keep the base and multiply the exponents. 5 to the power of negative 3 over 2. So this is the point where you can do your therefore. Okay? When you've got 5 to something equals 5 to the something else. Okay? So therefore, 3x is going to be negative 3 over 2. The exponents have to be equal, in other words, for the sides to balance. But now, it's not 3x I want, it's x. So I have to divide by 3. How do I divide negative 3/2 by 3? Multiply by the reciprocal. So negative 3 over 2 times, the reciprocal of 3 is actually 1/3. Which is going to give me negative 3/6, which reduces to negative 1/2. So you can see, like, there's a lot more steps for these ones. Okay? You just have to go step by step. That logical train of thought, you have to show each step logically until you get to this one, where you've got base to exponent equals base to exponent, then your therefore statement, and then sometimes there's a bit more work to get to the answer than yesterday because fractions are involved a lot more often. Okay, so here's our first example where we would need a common smaller base today. we don't know that yet. We'd still start off the same way we normally would. So I would first rewrite the bottom in exponential form. And then I want it up in the numerator, so I would make it 128 to the negative 1/2. And you look at your 4s, 4 cubed is 64, and 4 to the 4th is 256. So I have to have a common smaller base, and that common smaller base is going to be 2. So I'm going to rewrite 4 as 2 squared to the x. And I'm going to rewrite 128 as 2 to the 7th. But that's to the negative 1/2. Okay, so on each side now I have a power to an exponent, so I have to multiply the exponents on each side. So 2 to the 2x equals 2 to the negative 7 over 2. So that's at the point where I can do the therefore statement. So therefore 2x equals negative 7 over 2. Where I'm going to divide both sides by 2, which is the same as multiplying by 1/2. So I'm going to get x is negative 7 over 4, actually. Okay. Alright, I'm gonna let you guys try this one. Alright, so everyone's either got it or they're really on the right track here. So as I walked around, I saw everybody was able to get to that spot where you've got 2 to the something equals 2 to the something else. Okay? So then there's your therefore. X minus 3 equals negative 7 over 2. So what would I do to both sides? Add 3. Good. So we get x is equal to negative 7 over 2 plus 3. So I've got to add a fraction and a whole number, so I need a common denominator. So my common denominator is going to be 2. So I would end up getting x to be negative 1/2. Okay? All right, awesome. Next one should be pretty straightforward. First off, I would rewrite this side as 243 to the 1/2. Okay, and then I would see I can't write 243 as 9 to the something, because 9 to the 3rd is already 729. 9 squared is 81, so I get my common smaller base of 3. 243 is 3 to the 5th. Then you have power to exponent on both sides.
Thanks for the instruction.
Yes?
Is Anne declaring clause?
Yes?
Could she come to student service, please?
Sure.
Thanks.
So therefore, 2x is equal to 5 over 2. Means we have to divide both sides by 2. Dividing by 2 is multiplying by a half. So we should have got x to be 5 over 4. Okay? Any questions about that one? Okay. All right, this one looks complicated, but it's not. Just make sure your exponents look like exponents. I had a couple people that, like their 7 to the x looked like 7x yesterday, so make sure that doesn't happen, okay? Make sure your x looks like it's in the exponent. So I would do the bottom as 343 to the 1/4 instead of leaving it as a radical. Bring it up. So make the exponent negative. Then see if you can write 343 as 7 to the something. And you can at 7 cubed. So your power on your right side. Make sure you're at your therefore point. The bases are the same. The only way that we can be equal is if the exponents are also equal. How do I get x by itself in this style? Multiply by 3, good. So the multiplying by 3 end is the divide by 3. So you get x to be negative 9 over 4. Good. Okay, this is a good one. All right. Let me put a star beside this one. All right, so far this side's okay. But we haven't seen something that looks like this yet. How can I rewrite this so it's an exponential form instead of a radical form? Curious? Okay, so this is the exponent, 9x, and this is the root, 3. Okay, so that was our rule that when we had x to the m over n, it was the same as the nth root of x all to the m, but it was also the same as, and this is the one we don't use very often, but you need to know it, it's also the same as the nth root of x to the m. So what we did is we took this way of writing it and rewrote it as an exponent. Okay? So this is our exponent, the 9x, it went on top. This is our root, the 3, it went on the bottom. Okay? So we use it backwards. Okay? So 9x over 3 simplifies, doesn't it? So that's the same as 1 over 16 just to the 3x. Because 9x divided by 3 is 3x. And you could have combined that with the step of bringing it up to the numerator if you want. So that's going to be 16 to the negative 3x. So at this point, can I write 16 as 8 to the something? No, so I have to have a common smaller base. Okay? So let you guys finish it from there. Okay, so common lower base would be 2. How do we vote about that? Yeah. And then do the power of a power. So remember that this 3 multiplies both pieces. So you get 2 to the 6x plus 3 on this side. And 2 to the negative 12x on this side. Okay? So now you're ready for your therefore statement. So therefore 6x plus 3 equals negative 12x. I want to get my x's together. So I would divide both sides by negative 18. Did I make a mistake?
Well, wouldn't it be
Oh.
easier to move it to the positive side to deal with the positive numbers? Add 12 instead of taking 6.
I could, and then I would have to subtract 3 on that side though. Right? I think either way I'm seeing it.
Yeah.
But yeah, I could, then you have to subtract 3. Do you see that? If I did that.
So it's not working with the x positive.
I normally do that, but I see that if I move this over, then I've got 0 on this side. Okay? And sometimes when you have 0 on the side, you don't see the side. Okay? But as long as you're good, it doesn't matter. So you'd end up with negative 3/18, which reduces to negative 1/6. Okay? Negative 1/6. Okay, that was a tricky one. All right, this one's similar, so I'll give you time to try this. So getting it to this stage would be where I see, can I write 32 as 4 to the something? No, so now I need a common smaller base. So 2. (32) is 2 to the 5th. And I'm going to do my power of a power. So I'm going to get 2 to the 2x minus 10 equals 2 to the negative 5 over 2. Everybody get it to there? Okay. So now you want to do your therefore. 2x minus 10 equals negative 5 over 2. And then there's a couple ways people would go about solving this equation. What would you do?
I added 10 first.
Okay. So then to add them, Molly, what did you have to do?
I put them all into the same.
Common denominator. So 2x equals 5 over 2 plus 20 over 2. Yep. And then 2x equals 25 over 2.
I got 15.
15.
It's a negative 5.
So negative 5. Thanks, guys. Those are good. All right, so then that's going to be, and then what would be my last step?
Divide by 2.
Awesome. So I would end up getting x is 15 over 4, negative 15, no, positive 15 over 4. Okay, how many people got all the way to 15/4? That's really good. Excellent. And remember this one here, when you're dividing by 2, you're multiplying by half, multiply by the reciprocal. Okay. All right, I is another one where we're going to use this idea here. We're going to change this to an exponential form. Okay. So our first side we would write as 25 to the x plus 4. But our second side we're going to write as 125 to the, so then 4x plus 2 is the numerator, over, what's the root? 2. If there isn't a little number in there, it's square root. Okay? Now, it just so happens that I can divide each of these by 2. Does everyone see that? So I can make this 125 to the 2x plus 1, because each piece in the top can be divided by 2. Okay? Then I would want to check, can I write 125 as 25 to the something? No, so I need a common smaller base of 5. Okay? So 25 can be written as 5 squared. And 125 can be written as 5 to the power of 3. Do my power to an exponent rule. Is you okay? Yep, okay. Remember to distribute. It's one of the most common errors. So then now we can say therefore 2x plus 8 is equal to 6x plus 3. And solve from there. If I want to keep them positive, I can subtract 2x from both sides, keep the coefficient of x positive. Subtract 3 on both sides. And divide both sides by 4. Which means x would be 5/4. Okay. All right. So now we have a base that is a fraction. We did ones like this yesterday. We didn't have the root symbols. So 3/4 to the power of x. And I can rewrite this side as 64/27 to the power of 1/2. This is square root. Everyone see that? And then I want to see, does the 3 go with the 64 or the 27? 27? So if I flip this fraction, I have to change that exponent to the negative. So that would be my next step. 3/4 to the x is equal to 27/64 to the negative 1/2. And now I want to write 27/64 as 3/4 to the something. I'm going to need double brackets here. Here's my outer one. My inner one is going to be 3/4 to the left. 3, good. So 3 to the 3 is 27. 4 to the 3 is 64. So you've got the right number. Okay. And you're going to do your power of a power on the right side. So that's going to be 3/4. Make sure you put it in brackets. A couple people forgot the brackets on the right side yesterday. You need the brackets because it's the whole fraction to that exponent, not just the numerator. If you don't do the brackets. Okay. And then we're ready for our therefore statement. We've got the same base on both sides, so therefore x equals -3/2, and x is already solved for. So that's our answer. Okay, and our last one. All right, I'll let you guys try that one. Okay, so everyone's first step was rewriting this side in brackets to the exponent of 1/2. Okay, and then looking to see whether the 3 and 32 went together or the 3 and 243 went together. So we had to flip the second one. And make the exponent negative. Oops, I forgot the x here. And then I need to rewrite 243/32 as 3/2 to the something. And that something is 5, good. To the -1/2. 3/2 to the x is equal to 3/2 to the -5/2. Therefore, x equals -5.